Hi all, welcome to Chemakhilam Field Chemistry. Today we can discuss about C13-NMR. If you did not watch videos related to proton NMR, please watch those things because the fundamentals of NMR spectroscopy already explained. If you have an idea about that, it's very easy to understand C13 because in proton NMR we have discussed almost all things. The theory part is almost same for proton NMR, C13 NMR, F19, P31, whatever that active nuclei or the whatever NMR available, all the theory part are same. So first you watch or you have to build an idea about the proton NMR. Then you come to C13 NMR or any other heteronuclear NMR. Okay. I will put one link in the description box. Or otherwise you can check the playlist in that. Spectroscopy one folder is there. I think more than 13 or 14 videos are there. You can check that thing. And first you build or you should have an idea about the proton NMR. In proton NMR we have discussed number of signals, chemical shift, and what the difference is. Chemical shift value will be different. The theory or the base will be same for any of the NMR. Okay. Now let's have a look at C13 NMR. The first point is C13 nucleus is less sensitive than proton. That is the first point. And C13 means you know that carbon have three isotopes: C12, C13, C14. C12 is inactive because its I value is 0. For C13 the I value is 1/2. And for C14 it is radioactive. So C13 is the active nuclei and it is less sensitive than proton. And due to that, also due to low abundance of C13, there will be no coupling between two carbons. And if different carbons are there, it will give different signals. But one type of carbon cannot split another type of carbon, and where the splitting will come or where the multiplicity will come, the multiplicity is arises from the other active nuclei present in that molecule. If C13 is bonded with some hydrogen, then hydrogens can split C13, or deuterium or any other active nuclei like hydrogen, D2, F19, P31 or any other rhodium like that. Lot of active nuclei are there. If any of them present near to carbon, it can split that signal arises from carbon 13. And due to long relaxation time, there is no meaning of integration of signal to find out the number of carbon atom present. That means if you did NMR or if you have seen that NMR spectrum, we will get some graph. We have to integrate. While integrating, we will get number of hydrogens. But for carbon, while integrating, we are not getting exact number of carbon present in the molecule. That is the meaning of this sentence. In proton NMR on integration, we will get number of that type of hydrogen present. For example, if you are considering ethanol, that is CH3, CH2, OH. In that, three types of hydrogens are there. One is CH3 hydrogen, other is CH2 hydrogen, other is OH hydrogen. So these three will give 3 peaks. So we are getting 3 proton NMR signals. While integrating the graph, we are getting like 3 hydrogens are there, 2 hydrogens are there, 1 hydrogen is there. But in the case of carbon, it won't give that number of carbon atom present in the molecule. That is the meaning of this sentence. That means due to long relaxation of C13 compared to proton, there is no meaning of integration of signal to find out number of carbon. But in the case of hydrogen, integration will give number of hydrogen present in the molecule. And here also number of signal means number of non-equivalent carbon, and chemical shift means it gives the presence of electronegative atom is there, or a pi bond cloud. or the hybridization. Like whatever we discussed, factors affecting chemical shift we already discussed in the case of proton NMR. Same thing is applicable here also. Chemical shift value means it will give an idea about whether the carbon is sp3, sp2, sp, or it is attached to an electronegative atom, or it is attached to an electropositive atom, or it is present in the pi cloud. Like that, lot of information we are getting from chemical shift. And integration, already mentioned that integration won't give number of carbon, but it will give some ratio, like 1:2:3, like that one ratio it can provide. And the coupling means that or the signal is multiplied, or signal is splitting. Signal splitting is that means the type of neighbors present. It will give an idea about the neighbors. And enantiotopic carbons are chemically equivalent, so it will give one signal. And diastereotopic carbons, they are non-equivalent, so they will give different signal. And enantiotopic and diastereotopic, in stereochemistry, it can be explained on the basis of stereochemistry. Those carbon means enantiotopic carbons are equivalent, so it will give one signal. Diastereotopic carbons are non-equivalent, so they will give different signal. This is the basic thing regarding the C13. That is, C13 is very less sensitive, and there is no coupling between two carbons, and the multiplicity or the splitting results from the neighbor active nuclei. And due to long relaxation of C13, the integration have no meaning, or it won't give the number of carbon atom present in the molecule. How many number of non-equivalent carbon present, that much signal you will get. And chemical shift value will give an idea about the type of carbon present. And integration, it can only give the ratios. It cannot give the exact number of carbon present in them. Each type, how many carbon present, that won't give. And the coupling means it gives an idea about the neighbors. And enantiotopic carbon means they will give one signal, and diastereotopic carbons will give two signal. And when this is applicable means when we are considering ring system, it will be very useful. Okay, I think these points are now okay for you. If you have any doubt, you can comment. And we can see some chemical shift value. If alkyl carbon present, then the value will be 10 to 40 ppm, in between 10 to 40. If OCH3, that sp3 carbon attached, or OCH2 electronegative atom, means CH2 with some electronegative atom present, then it will give 40 to 80 ppm. If acetylenic carbon present, it will give 80 to 100 ppm. Then alkene or aromatic system present, then it will give 110 to 140 ppm. Aldehyde or ketone present, it will give 160 to 220 ppm. And ketone have nearly 200 above, 200 plus. If some 200 plus value you got, then it is a ketone. That is that point you have to remember all the time. More than 200, that means ketone. Ester, the range is 160 to 165. If there is an RCH3, it will give 0 to 35. If it is R2CH2, then the range is 15 to 40. R3CH, then 25 to 50. If all valency field, that is R4C, it will give 30 to 40. And this value will be different if some electronegative atom present in the molecule. Okay, it is similar to what we explained in the case of proton NMR. Please watch those videos, factors affecting chemical shift. Then you will get a clear idea regarding that. These values are rough values, and in that if 200 plus value is there, then there is a ketone. that range you have to understand. And the alkyl carbon means it is 10 to 40. In the first alkyl carbon present, it will be 10 to 40, and if it is in the form of RCH3 then 0 to 35, R2CH2 means 15 to 40, R3CH means 25 to 50, or R4C means it is 30 to 40. That also this aromatic or alkene, it will be 110 to 140 ppm. These values are very important while structure elucidation. Okay. If you want to by heart this value means, I think while practicing you will get an idea regarding these values. It normally comes. Okay. The value you have to note down is for aldehyde and ketone, aromatic alkene, and this primary, secondary, tertiary values, and this acetylenic value. I think these are the fundamental values. If you can, you just remember all those values. That is better. But when we are doing that examples, for you it is maybe you feel difficulty because while practicing you won't able to understand these values, because while studying these values you cannot solve the questions. While practicing the question only you will get the values. Okay. And now we can discuss some question related to C13-NMR. Only that much we can tell about C13. Others are exactly similar to proton NMR. So by repeating those things, there is no meaning. Okay. Now we can discuss some questions related to C13. First question: how can we differentiate the following compound on the basis of the C13-NMR? These are the three compounds. This is 1,2,3 trichlorobenzene, and this is 1,2,4, and this is 1,3,5. And don't okay, sometimes you may write 1,2,6 trichlorobenzene, but that's wrong. That IUPAC name nomenclature that you should understand, because maybe in question only name will come. You have to first draw the structure. If you know the structure, you can easily find out the number of carbons or different carbon present, or the number of signal present. But if an IUPAC name is given and you have to find out the number of signals, first you have to draw. For that you should have an idea about the IUPAC nomenclature, and for that you can check +1 textbook second part. In that some basic idea you will get, and after that you can check some other books for spiro compounds like that. I did one video. My initial videos are I think my initial video in that one IUPAC nomenclature is there. You can check that thing. I will put the link in the description box. I think it is related to spiro bicyclic fused ring name nomenclature. For these compounds, all +1 text is more than enough. Now we can do the question. First we can consider this compound 1,2,3 dichlorobenzene, and in that here one planar symmetry is there. Like this plane can cut this compound in equal halves. So this carbon and this carbon is considered to be isotopic, or these two are identical and these two are identical. So how many signals we will get? First signal means this carbon attached to chlorine, and second carbon is this carbon. Then 3, 4, like that 4 types of carbon are present in the molecule. When coming to this compound, there is no symmetry, so we can write as 1, 2, 3, 4, 5, 6 type of carbons present. When coming to this compound, here also planar symmetry present. Like that one plane we can write, or we can draw, and another plane is something like this, and another plane is this one. So 3 planar symmetry is there. So we can tell that the carbon in which chlorine attached will give one signal, and the other carbon which is in between two chlorine will give another signal. So this is first type of carbon, this is another type of carbon. So total number of signals will be 2. For first compound it is 4, second compound it is 6, and third it is 2. Okay, like this we can differentiate this compound with the C13-NMR. Next question, how many number of signals will appear in C13-NMR? 3 types of compounds are given and we have to predict number of signals. First we can consider compound A. There is a plane of symmetry, or this plane can split or this compound in equal halves. So the number of carbon will be 1, 2, 3, 4. 4 types of carbon is there. Consider this compound. Here also similar to our last example, one plane like this, one plane like this. So we can tell that this bridge position, when we are considering the bridge position, it will give one type of carbon and the other will be similar, 1, 2, then 2 types of carbon present. When coming to this point, this compound, and there is a plane like this, and this is passing through this one, this carbon and this carbon. So that also equally cut the compound. Then this is the first carbon, this is the second, third, fourth, fifth, sixth. So 6 type of carbon present. So in the first compound 4 types of carbon, second carbon 2 type of carbon, and in third it is 6 type of carbon present. I think this is a previous year's ESIR question. Now next question, number of signals that appear in the broadband decoupled C13-NMR spectrum of phenanthrene and anthracene respectively. This is net June 2012. Decoupled C13-NMR spectrum means there is no coupling between hydrogen, means in phenanthrene and anthracene carbon and hydrogen present, that hydrogen can split the carbon signal, but here it is telling, or it's mentioning that decoupled C13, that means there is no coupling. So we have to count different types of carbon. Now we have to understand the structure of phenanthrene and anthracene. If you don't know the structures, you are unable to do the problem. Phenanthrene means this is the structure of phenanthrene. Here also you can see one plane of symmetry, and then you can count carbon 1, 2, 3, 4, 5, 6, 7. So 7 carbons are present. So you can eliminate the option A and B. Now consider C and D. Then this is a structure of anthracene. Here also you can see 2 planar symmetries. So we can count 1, 2, 3, 4. 4 types of carbons. So the number of signals in phenanthrene is 7 and number of signals in anthracene is 4. So option 7 and 4. Option C is the correct answer. Next question, match the following. Some compounds are given and its C13-NMR shift is given. Acetic acid, acetonitrile, acetone and carbon tetrachloride. The values are 95, 115, 175 and 205. And I already told you that if there is a ketone, it's above 200. So there is a value of 205, right? So and these are the options. So acetone is correspond to 205. Then C is correspond to 4. C4A, B and D we can cut, because in B option C is 1 and option D in D C means 3. That 2 option we can eliminate. Now remaining these 2. Next, which one we can consider? See, this acetic acid also in the range of 160 to 180 range. So it is 175. next to acetone or ketone, acetic acid or acidic group will come. So the 175 the value will be acetic acid. It's option A belong to 3. So here A3, B2, C4 and D1. That is the correct answer. And now we can check the other options. Acetonitrile, it's 2, 115, and option C, this is carbon tetrachloride, it is 95. R4 we have seen, where R means alkyl group. If some electronegative atom will come, then it will go to downfield. Downfield means higher chemical shift value. So the value will be more, or compared to when comparing these all, carbon tetrachloride will be like sp3 hybridized, so it will have lowest value. Like that also you can consider. Okay, so option A is the correct answer. And next question, the carbonyl resonance in C13-NMR spectrum, eta 5 C5H5 RHCO3 times, where RH is the an active nuclei with a nuclear spin I equal to 1/2, and it's 100%, that means subatomic is 100%, shows a triplet at minus 65 degrees Celsius owing to the presence of, and it's a question asked in June 2012. What the question? Actually, this compound, this carbonyl, it's coming in the organometallic compounds, but we can do this question. If you don't know the structure also you can do, otherwise in metal carbonyl you may study all these things while counting the outer electronic configuration also, like that you can arrange. But here how we can do, if you don't know the structure, still you can do this. Here metal is rhodium, and it shows a triplet means carbon C13-NMR shows a triplet, and that means it should attach to the rhodium. It's a metal carbonyl, right? So that carbonyl should attach to the metal. And now we have to find out whether that carbonyl is attached to a single single metal or two metals, or it's a three metal, it's linked to three metal, like that. We have to check. Okay, here terminal CO means that carbonyl is attached to one metal. Mu2 means it is attached to 2. Mu3 means it is attached to 3 bridged, 2 bridged. And eta 5 C5 mean C5H5, it will give single signal, and whether that is correspond to the structure, means splitting. But splitting is caused by what? This metal, right? Splitting is caused by metal. If we are considering this compound, that means C5H5, and the environment is same, so it will give one signal. And here due to it's not mentioning that due to hydrogen, this complete compound it is given, so we can eliminate this option D. Now we can consider ABC, whether that metal is the carbon is bonded to single metal, two metal or three metal. That we have to find. How we can find out? It is given that it is a triplet, and we know that what is the formula for number of signal or the splitting. Number of signal is equal to 2Ni plus 1. And now we have to consider rhodium, right? How many number of rhodium present, that we have to find out. So instead in the place of N, we have to that the value of N we have to find out. 2 into N into, and the rhodium have the spin of 1/2 plus 1, that is equal to 3, means triplet, right? 2Ni plus 1 value is 3, and now we have to find out N. This is what N plus 1 equal to 3, or N equal to 3 minus 1 equal to 2. That means N is 2. N is 2 means 2 rhodium are present. 2 rhodium are present means it is a bridged carbonyl, and all the carbonyl in a single atmosphere. That's why we are getting a single signal, right? So the option B is the correct answer, and this is the structure of this compound. Here you can see that this carbonyl, all the carbon is in the same environment, so it will give one signal, and each carbon is attached to 2 rhodium. So this carbon, one signal, it will split into 3, right? So this also a previous year net question, net 2012. I think this question also clear for you. If you have any doubt, you can comment. If you like this video, like, share and subscribe. And you can follow me at Chemakhilam Instagram page, Facebook, or you can mail me. Don't forget to press the bell button. Then only you will get the notification when I am uploading the videos.